Let's see how we can trace the X signals, the unknown signals during the simulation, and then traverse them to the source using the tools that Riviera-PRO provides. I'm going to start the simulation in a moment, but first let me explain what this macro will do. It'll initialize the simulation with the top level, and once that is done, it'll execute Xtrace command that tells the simulator that it needs to monitor some of the signals for the X values, for the unknown values, and I've used it with some of the parameters here. Let me close the library manager. So first of all, whenever an X value is met, the simulation must be stopped, and when it displays the information, I wanted to display the driver's information and also the time when that X value happened, and I wanted to be linked to the tool called Advanced Dataflow. That is so that I could then explore that signal and get to the source of it. And also I want to create a text-based report in this specific folder. Stop condition 1 means that I only want to see the X value reported for a given signal one time. So if it happens multiple times on the same signal, only one instance will be reported. And I want to add all of the signals recursively, starting from the top level, and the wildcard means that I want to add all of my signals. And last, in this macro, I'm also logging all of my signals. This is so that I could add them to the waveform at any time, and I would have the simulator would log the values, so I get access to the values at any time. Let me execute this macro so that my simulation will get initialized and that my Xtrace engine will also be initialized. And as I can see, 84 signals were Xtraced and 84 signals were traced in my simulation database. Now let me just run the simulation, and I see that it's almost immediately stopped at the time of 160 picoseconds. And I see that multiple signals, perhaps connected, have received the unknown value X. Now this wouldn't have been reported if the value X was assigned from time 0, so it means that this signal, and I can actually verify that on my waveform, originally had a known value, and then at a certain point, which is this time, was assigned an unknown value. And the process that assigned an unknown value is this. Now, since I have requested to have a cross-probing with Advanced Dataflow, I'm going to leverage that. By double-clicking on that guy, it opens up the Advanced Dataflow here, and I can see my off signal being highlighted, and also it opened up the whole net all the way down to the X signal source. So all I'm left to do is basically to visually follow it with my eyes until I reach the end of it, of this net. And it seems like this process is where it ends. The blackjack signal source is an X value, and it's been the input and the output of at the same time. So the answer to the question must be in this always block. Let me look at the blackjack signal inside of that always block. So to get to the source, let me right click and select show source instantiation of that always block. Here's my blackjack signal that I know has value X, and the tooltip actually does show me that it has value X. And let's explore this process. It's supposed to be assigned, the blackjack signal, supposed to be assigned under the new G, which works as a reset signal. Let me add this guy to the waveform viewer so that I can then analyze it. And let me also add the new G signal to the waveform viewer for the same purpose. Now, even if I just put my mouse over the new G, I can see that it has value 0. And if I look at my waveform and zoom out a little bit, I can see that new G had value 0 from the beginning, and so had the black jack. So the answer to this is that because new G hasn't been asserted with 1, that is why the black jack hasn't been initialized yet. And because black jack hasn't been initialized yet, that's why all these X values, they propagated all the way from this block to this signal. And if I add this signal to the waveform, which I can do now from Advanced Dataflow, here's what I can see, and that proves my theory that the signal off had a known value up until the current simulation step, when it was assigned black jack signal, which was unknown. That is why we've never seen a report for blackjack signal, because it's been just simply uninitialized from the beginning. But we did get the report for value for the signal off, which went from a known to unknown. And if I continue my simulation further, it actually didn't go any further, because it stopped again at the same time with yet another signal being assigned a value X. And if I double click on it and focus my Advanced Dataflow, I can see that there is another net with the X value on it. And interesting enough, it leads me to the same exact process. So the reason for those X values is again the same process which I've already investigated, and I know that it hasn't been initialized yet. So let me go ahead and continue the simulation further all the way until it stops. There will no more detection of X values. And if I look at my waveform viewer and go back to the previous time of 160 picosecond, zoom out, what I see is that signal off was toggling from known to unknown all the way until new G pulse, which initialized the blackjack signal, and that in its turn cleared out all of the unknown signals. Now when I end my simulation, I can also go and look at my Xtrace report right here, and everything that's been reported in the console I also see in one report file. This is good for the offline processing of the simulation data.